Hey, hi everyone. Today we have Sneha with us, and it's been some time when we started super movers throughout India, and we have been going to different cities, teaching about people how to get started with Aptos. But with so much movement, there are some slip and nooks which gets missed around, and we didn't want that to happen to you. The whole experience of super movers is to onboard you onto Aptos and the Move ecosystem and for you to understand why we are truly doing this. And Sferon and Aptos are truly dedicated into understanding that what tools and whatever knowledge and resources are required for you to be a better developer, we are here to suffice you with that. Today, I have Sneha with us, my good friend and a DevRel of Aptos Foundation. She's also here to tell you about the how to get started on Aptos from scratch. Because in IRL meetings, there are many things which does get missed out. And Spheron and Aptos are very much towards one goal of onboarding every developer onto Aptos at a time. So towards 1 million developers. Thank you so much for watching today's stream. The stream would be segmented into few parts where Sneha would be giving you the intro of Aptos and then get you started on building on top of Aptos. Now, if you have any questions or if you have anything, we would want that you would use YouTube chat or Twitter chat or anything which you would be using for your Q&A, and we would give 15 minutes in the end specifically for Q&A. So over to you, Sneha.
Okay, hi everyone. Thank you for such a warm introduction, Prakash. So I'll just lay out what today's session would look like. So first of all, I would like to take some time to speak a little bit about what is Aptos and why Aptos. Why should you build on Aptos, right? And then we'll get a little bit into Move language, which is going to be the smart contract language for Aptos. And that will be followed by a small module that is a smart contract on Aptos Move that we would be building and deploying. So yeah, that's how today's workshop is going to look like. If Prakash, are we good to share the screen and go ahead with
Yeah,
the
please go ahead.
presentation?
Yeah, sure.
Awesome. Prakash, just want to make sure that the screen is visible.
Sneha, it is. Just go ahead. Can you hear me?
Okay, cool. Okay, so starting up with Aptos, just want to take a quick moment to introduce like a little bit about me. So I'm Sneha. I've just started working as developer relations for Aptos Foundation. Previously, I was involved. I've been in the Web3 space for close to 4 years now. I was previously building my own company called Social 3, where we are building a Web3 professional network, and prior to that, I have worked around smart contract development on the Solidity side of things. So, yeah, that's a little bit about me. I've also been very much immersed in the open source space, primarily working with organizations like Public Labs and Moja Global for programs like Google Summer of Code, OutTG, Google Season of Docs. So, yeah, that's a little bit about me. I'll just very quickly go over to what is Aptos and why Aptos, right? So, a little bit about Aptos. Basically, if you folks have worked in Web3 before, if you have created dApps on Solidity, if you have been working with libraries like Ethers.js on the front end side, or if you're working in the Solana ecosystem on Rust, you would have a little bit of an idea about what is a blockchain, and even a little bit about the kind of applications that we normally see in blockchain. So, if today the main problem that we see around blockchain lies with building consumer applications. Today, it's very difficult to onboard people onto blockchain. We need to have these kind of events a lot because right now there's not a very concrete example of an application which can be used by millions of people in a day-to-day basis. For example, something like a TikTok, something like an Instagram. And the reason that is not possible on blockchain is primarily because as and more we get decentralized, it gets way difficult for us to control the scalability of the system, to control the security of the system. And that's the major problem that we are seeing with blockchains right now. Um, and what ends up happening is that either your blockchain is too centralized if you're trying to scale it up, or if it's too decentralized, then the throughput of the blockchain is not as much. Just to give you a rough understanding of that, if you look at Solana, then it's like some 2 to 3K transactions happening per second. If you look at Ethereum, you'll get like 12 to 15 transactions per second. So the throughput that is coming out of the blockchain is pretty small if we compare that to applications like Web2 applications like Instagram or YouTube, right? So it's very difficult to create something that can essentially match the request latency that we see in Web2 applications. And this is the reason why we need to think of blockchain, but we also need to think of blockchain for consumers, like consumer focused applications, right? And that is only possible when we are able to solve the performance issues which are happening in blockchain right now. And this is how the idea of Aptos came up. So, a little bit about Aptos and how it started. So, Aptos was basically um it was basically created within the Facebook team. So, Facebook team wanted to create a blockchain where they wanted to solve this problem of micropayments, settlement of micropayments across the world. So, because of the creator network that Facebook has created very brilliantly, they wanted to figure out a way to send small micropayments. And settle them in a very seamless manner from people from different nationalities can use this technology that are like situated in, let's say, Philippines or India or South Korea or wherever, right? And to create such a technology, it makes the most sense to use blockchain, because the reason why Bitcoin came up as a payment layer was because of these benefits that are possible through blockchain, which is not possible otherwise, in terms of like digital currency, digital payments, right? And that's how the initial origin of this idea came up. But unfortunately, due to regulations in the US, the project was shut down. And the team that was building this project internally actually came out, and then they created two different teams out of it. One was called Aptos, one was called Sui. And these are two layer one blockchains that came out of it, which has the original team that was creating or building within Facebook this particular blockchain. And at that time, it was named the DM or the Libra blockchain. So that's a little bit about the history of how Aptos came into the picture, right? And internally for this particular blockchain, they also ended up creating a domain specific language for this blockchain, which is Move language. And if you have probably worked with like React.js or something, you would understand that React.js, again, this is open source right now, but this was actually an internal tool that was developed by Facebook engineers. So just like that, we have Move language, domain specific language for blockchain. And then there are variants of it, and Aptos has its own variant known as Aptos Move. So yeah, that's a little bit about just setting the stage for what is Aptos and how Aptos just came into the picture. So what is this goal of Aptos? So one goal that we are sticking by is, if it is happening in Web3, it is happening on Aptos. Um, and I want to talk a little bit about the tech in terms of like what is possible in Aptos. So a few things that I've already talked about is providing a low latency, high throughput blockchain, which again is something that is very, very difficult to find right now with the current blockchain technologies. We have come a long way from where we started in terms of blockchain, but in order to, and we also, and I also believe that personally we will go much further for all of the existing blockchains. It's just that the tech that Aptos has adapted is like very different and very forward thinking in terms of where we can end up like a couple of years down the line, and how we can power applications. And this is possible through a couple of different things. I want to take some time and speak a little bit about all of these things. But before that, just wanted to show you a little bit of the stats that we have over here. We have sub-second finality, so very low latency that happens, end-to-end sub-second finality that happens for the transactions. The cost efficiency in terms of NFTs, like less than $0.007 for every NFT, and so you can do 10K transactions for $0.34. We are also very much focused on the user experience for the particular blockchain. So there's seamless onboarding. So we understand that a lot of users right now in Web2, they do not understand this concept of wallets. What they are familiar with is the social logins that we see, like signing in with Google, signing in with GitHub or something else. So how can we ensure that the system has that kind of onboarding experience? And then we also provide a lot of SDKs. So we understand that not everyone would be interested in learning Move language, right? So how can we ensure that they can maybe pick up and still deploy applications around creating tokens, around creating NFTs? So we have our robust network of like libraries that has been already created, which is accessible through our SDKs, our TypeScript SDK, Python, Rust, if you're into gaming, Unity. So you can just go ahead and use your SDKs, and that will give you a full-fledged support to create any sort of applications that you want in terms of like our token libraries and FT libraries. All of them has been built out pretty well, and with a lot of flexibility in terms of your output. So yeah, that's a little bit about Aptos. I think just want to show you one more slide here in terms of build with us, why you should be building with us. So the companies that you see over here, Google, Microsoft, Coinbase, these are all companies that we have partnered up with and are doing some sort of activity with the MasterCard, Visa. So that's something that I wanted to show you over here. And just want to pause here and then move to another slide, basically, where I'll be talking a little bit about intro to Move language and how you can get started with Move language. So till that moment, I would be happy to take any questions that you folks have. And I'll just pull up the slides in the meantime. Okay, just give me a minute. Okay, so let's talk a little bit about Move language. So as I'd mentioned, Move was originally designed within Facebook in like 2019, 2020. And Move language has been designed to uh, basically kind of offset the kind of risks that we have been seeing in blockchain applications so far. We have been seeing languages like Solidity, which is fairly easier for people to pick up initially. But the challenges that happens with it later on are a lot. So before we get started on with this workshop, I want to take a moment and I just want to talk about money for a moment, like just straight up cash money. So if you're talking about cash, right? Couple of major properties with cash lies with that cash cannot essentially be like copied, and cash cannot be like deleted or like destroyed out of the system. I mean, you can physically tear up a note if you want to, but if it's in the system, it's like supposed to be consumed, and that's how it gets like it loses its value. You give it to someone in exchange for a product or a service, and that's how it loses its value, right? Like that's the understanding of it. Um, But what happens is that when we're looking at languages like Solidity, a lot of that characteristics of money or cash, where we're saying that it cannot be duplicated or it cannot be dropped out of the system, that is not something that these languages are able to capture well. The reasoning being that they treat money or cash simply as a number. And when you're treating something like money or cash as a number, you will eventually run into problems like overflow, underflow, and there will be all sorts of attacks that are possible because you're not essentially thinking of it as a digital asset, which is what it should be supposed to be treated as. And that's where Move comes in with its concept of resources. Resources are just special structs. Structs is something that we had learned about in terms of like classes and structs. Structs can just store data of different data types, right? So resources are special structs which cannot be copied or dropped. So what you're doing here is that by saving something as a resource, you're putting it as an asset, and you're giving certain properties to that asset. And that's exactly what Move language is trying to do. It's not trying to save things like NFT. It's not trying to save things like tokens as numbers, but it is essentially adding some more properties to that particular asset class so that it is defined initially in a way that the developer does not need to put in a lot of efforts to make sure that there is no misuse of that particular entity, right? The onus is not on the developer to make sure that there are mistakes in the code, but that onus itself on the language, that it's designed in such a way that you don't need to worry about it. You can worry about the coding bit if you have defined the things right in the beginning. So Move is designed for usability, safety, and performance. Let's go a little bit deeper into these things in the next slide. So first of all, let's talk a little bit about the usability aspect of Move. So we have a lot of rich libraries, frameworks, and ready-to-use standards, which is like in terms of our token standards, and which is our digital asset and fungible asset standard. So these are libraries which are built out completely, which can enable you to just like import and create sort of very different sort of applications which is possible. Like you can create soul-bound tokens, you can create unlimited limited supply, you can create dynamic NFTs, you can create composable NFTs. All of this is possible through our token standards itself, and it is written in a way which is very flexible. So essentially you might not even need to create very custom token modules or something, because a lot of that functionality will come right out of the box using these libraries. um, Another thing that I want to talk about is basically the safety that is provided through the ownership model that Move has. Because for everything that I mentioned, like because we are defining it as a resource, you're defining whether the data can be created, updated, deleted. All of that is being set in the beginning itself. And this is very important, especially when we're talking about any sort of DeFi based applications. If you're defining beforehand like what the entity like can do, like in terms of the different abilities that that particular entity has, you are assuring that hey, these things are not possible, and you can make sure that there is no absolutely no way that a piece of code will run where you're trying to delete or drop something which cannot be deleted, or if you're trying to duplicate or copy something which cannot be copied. So yeah, there is also a lot of importance given to where and how the storage works in terms of Move language. If you see the concept of accounts and how storage works with Solidity, it's like the data is stored under the smart contracts, but here the ownership is more on the account side of things. It's similar to Solana, the account storage sort of a model where the data is stored within the account, whatever things need to be saved over there. And it makes a lot of difference in terms of any sort of access control that you can provide later on, and also simplifies whenever you want to index or access things from a particular account as well. So it's a very good model. I want to talk a little bit about how Move's features have been coming from Rust, which, as you would know already, it's a very performant language, and it has a lot of flexibility and richness that it can offer. But Move also takes away the like difficult memory management aspect of Rust away from it. It's very domain specifically built for coding on the blockchain. So you will have things like resources, etc., which are not possible on Rust. Rust is more of a general language, and you can code a lot of different things on it. But with Move, it's more specifically designed for coding for the blockchain. So yeah, that's how you can go ahead with it. And as I mentioned, data is structured as resources on every account, user's account or object. So it's very easy to locate, read, and write. So there's also upgradability. Upgradability is in terms of the contracts that you see. You can go ahead and upgrade your contracts, and the upgradability concept is also a little bit different than how we see it in terms of Solidity, because it is a bit more safer, and it enables the users to understand at first glance how the applications they interact with are governed. So that's a little bit on this front. um, so yeah, as I said before, also some rich NFTs and all of these fundamental things which are possible over here in terms of our features. We also have this on-chain randomness. We do not need to rely upon an oracle to get any sort of randomness, like random numbers data. Instead, we have it inbuilt within the blockchain to be able to access that. And we have advanced concepts for account abstraction. All of these things are building, where you can have any sort of if you would have seen Solidity, we would have relayers for any sort of sponsor transaction, but all of that is possible natively in terms of the way we are defining a transaction here. You can go ahead and get like have a multi-sig, go ahead and pay for it. You can define who will be the fee payer for a particular transaction. All of those things are possible here. Um, so yeah, that's a little bit more on the Move language. And again, there's like frequent updates which are happening constantly all the time. We're also gonna we are also coming up with Move 2 and a new version of the Move VM. So let's talk a little bit on the safety side and how it differs in terms of the language safety. um, so we have all of these different layers of security that you can see over here. Let's talk a little bit starting off with the language safety side of things. So, if you would look at the different languages that we are interacting with, right, there are some languages which are more strict and some languages which are more flexible. If you're talking about type safety, you would have seen that there are certain languages where you will need to explicitly cast a data type into a different one or implicitly cast it, right? Now, imagine a system where you're giving it a particular data type and it automatically converts it and like changes it into a different data type. It's much harder to understand what would be the expected output out of it, right? So Move here has type safety, which ensures that there are like very like there are not mistakes which are happening during this conversion side of things. Modular encapsulation, this is just basically defining the kind of access control that can happen for the resources that are the special structures which we have defined, where they are stored, whoever like whichever like module or the smart contract can be allowed to access that particular resource and to what degree it can be accessed. Ownership and lifetime, which talks about again the same concept of data. We are setting the different abilities for each type of data, what can be copied, what can be dropped, and what would be the scope of that particular like data or value. Referencing safety, so this is basically like if we are deleting something that we have referenced, so there should not be a dangling reference without that borrowed value actually the main value actually being there or not. So the scope of the reference should also end along with whenever along with the value that we are borrowing from. So we have all of these inbuilt language safety principles. So when we're talking about bytecode verification, so whenever new smart contract gets deployed, so automatically we are processing this through this bytecode verification. So it's basically just saying something like your high level language basically gets converted into bytecode, and we want to ensure that the main script that we had, which is being converted, the smart contract, whether it matches our bytecode or not. For example, there might be hackers who might try to inject malicious scripts not in your smart contract itself, because it's harder to break into that because of the moves language safety principles. But instead, they might try to do that not there but within the bytecode. So we have to ensure that the bytecode that has been generated is also correct. Um, it's sort of like a last mile check that has been set up to make sure that we have the right this thing. Formal verification is a very interesting thing that you can go ahead and study about using the move prover. Uh, so what we try to do is that for every function, we have to define what is the expected output that will come out of it. And this is extremely important when we are talking about things like DeFi. If you rely heavily on formal verification, you can eliminate a lot of logical errors that are possible. On the scalability side, just want to talk a little bit, not so much about Move, because this is more along the lines of the scalability that has been provided by Aptos itself. That is our parallel processing block STM. So we have this parallel processing engine known as block STM. And if you would see in Ethereum, the transactions are sequential in nature. If you would look at Solana, Solana has a parallel engine. But the way that Aptos' block STM differs from both of these two different blockchains lies with how the parallel processing engine has been designed. It has been designed in an optimistic manner, meaning that it basically takes the different inputs of the transactions, and unless there is some overlap, it will just go ahead and optimistically run all of the transactions. And if there is some overlap that is happening with the transactions, it will go ahead and revert at that particular point of time. And what this helps us in doing is that the best case scenario for this execution is much much better if we compare it to the other blockchains. Solana also has a similar parallel engine, but it works along the ways of trying to first assign different transactions, like in different parallel threads, depending on what kind of overlap that they are having. Account overlap, where same account is maybe getting updated. So that assignment happens at the beginning, which takes a little bit of overhead time. So the latency might not be the best in terms of a best case scenario that can happen. And again, this parallel processing engine and the way that everything has been structured is heavily pipelined, this entire flow. So if one thread is processing something else in some part of the transaction, there's some other thread which is processing some other part of the transaction. So there are no bottlenecks that are created within the system which can allow such fast execution. So yeah, that's a little bit more about Aptos Move. Just the stat over here, which you can see, like 1 million sequential NFT mints, which are completed in 90 seconds. So yeah, that's a little bit about Move language. I hope that helps you folks understand a little bit about Move. Okay, awesome. So, I think this would be the perfect time to now start getting a little bit into the coding side of things. Prakash, is it cool if I can drop links here in the chat, or where should I share them?
Sneha, can you hear me?
Yeah, am I audible?
Yeah, you are.
Yeah. Yeah, I was asking, can I share the links in the chat or?
Yeah, you can give us
Okay,
like
perfect.
share the links with me, and I'll go ahead and
Okay, okay, perfect. Are there any questions so far?
no.
Okay.
So I'm gonna give you the access again.
Okay. Uh, So now I think we can get started with the building side of things. Uh, so I'm just gonna pull up this. I give me 1 minute. Mm. Okay, so for the workshop, I'll just give you a very quick overview of what we are trying to build and how we are planning to build it. So today we're gonna do a very simple smart contract deployment on Aptos. We're going to deploy a smart contract which will allow us to just attach a message resource to our account, and we can also override the message resource if you want to. So yeah, that's what we're going to build. And how are we going to build it? So first of all, we will start off with installing the Aptos CLI, which will allow us to spin up Aptos accounts to the CLI. It will allow us to fund our accounts to the CLI. And for even advanced users, it can be used to run a private Aptos network if they want to locally. So yeah, that's a little bit about the CLI. So the Aptos CLI will enable us to create the Aptos account. And post that, what we will be doing is we'll be creating uh, a using the Aptos CLI, we'll be creating a directory structure to basically set up our smart contract code, all of that. And that will be followed by understanding the smart contract code, what it means, and then finally it will be ending up with us setting it up and going ahead and deploying all of that. So yeah, so let's get started with the Aptos CLI installation. So for installing the Aptos CLI, we have the couple of different operating systems here. So if you are a Mac user, then the installation is pretty straightforward. If you have Brew, which I think a lot of you folks will already have, you can just go ahead and do a Brew install Aptos. That should be good. And then you can just run Aptos to verify that the command has run successfully and it's working for you. If you do not have Brew, then first of all, you can go over here and you can just install Brew onto your Mac. Now, if I'm talking about Linux, so in case of Linux, what you can go ahead and use uh, is basically just like a curl call over here. Um, and yeah, just add it to your path and just run this to make sure that this is working. And for Windows, also, it's a similar thing. Uh, So for Windows, we would like to install via the pre-compiled binaries. We'll be going ahead with a very specific version for the Aptos CLI. So we'll be going for the version 3.4.1. We do have the 3.5.1 release, but I just believe this version is a bit more stable, so might be better to go ahead and install this one. So what you can go ahead and do is just take this Aptos CLI 3.4.1 Windows version, go ahead and download this. This will give you a zipped folder. What you can do is you can go ahead, unzip this folder, and you can just do an editing on the environment variables. Uh, yeah, just unzip the zip folder and then copy this path to the executable up to this point. You don't need to copy this, just up till this point, and you can add it to your path variable. So you can just go to your Windows search, you can just do a edit environment variables. You will be able to see the environment variable that you currently have. In that, you will have a path variable. You can go ahead and edit that, and you can add this path up to this point as an entry, as a new entry in that path variable. So that is how you can get this thing working, right? So yeah, that's how you can go ahead and get this thing working. You can open a new PowerShell and then you can just run Aptos over there. Just write Aptos, click enter, and that should be fine. Another way to do it, with if you don't wish to add this to your path variable, is just to copy this entire path and then just run this entire path space help. But that means that every time you will have to run this command, you'll have to copy this entire string because it's not added to your path yet. So yeah, that's how you can go ahead and install the Aptos CLI. Um, awesome. So once you are done with this Aptos CLI installation, we can start off on the uh, yeah. So once you're done with the Aptos CLI installation, we can go ahead and start off with just creating a new account on Aptos DevNet. So Aptos has a couple of different testnets. So we have mainnet, which is production, which we won't be using obviously, and then we have DevNet and testnet. DevNet is the most preferred environment for developers who are just want to just develop some test code. So what we'll go ahead and do is we'll just open up a new terminal. Um, just give me 1 minute. I'll just share my screen. So yeah, what you can do over here. Uh, sure. Okay, so I'll just go ahead and explain again this CLI bit. So what we are doing here first is we are just installing the Aptos CLI. Depending on your operating system, there are different ways to install it. If you have Mac, the process is pretty straightforward. You can just run a brew install Aptos. That's it, you will have Aptos installed. If you don't have Mac, if you have Windows or Linux system, for Linux, the process looks like this in terms of just doing a curl on your terminal. And then you can add it to your path if you want to. And for Windows, it's a bit different. What we are doing is that we are installing via pre-compiled binaries method. We're going to this Aptos CLI release page over here. You can go ahead and click on this. Um, Over here, you can see, you can find the version 3.4.1. So you can just like move, scroll down, and here we have the version Aptos CLI version 3.4.1. We have the assets over here. And here we have the Aptos CLI 3.4.1 Windows. So you can just go ahead and download this one. This will give you a zipped folder. You can unzip the folder. And what you will have to do is that after unzipping, you can just go ahead and copy the like path to this, right? This is the path that you will get. Uh, but just copy it till this bit, exclude this aptos.exe part, just copy it till this bit. On Windows, you can just go to your search bar and click just like write environment variables. So it will allow you, give you the option to edit environment variables. If you open that, you will see like a control panel prompt just opening up. In that, you can find your path variable. There will be a variable named path. You can go ahead and edit it. In that, you can create a new entry and you can just copy and paste this particular path. Like just don't copy this path, this is which is given over here. Copy the path which you will have for your own system, wherever you have unzipped that particular folder, but exclude the aptos.exe bit in that. So once you copy paste that particular path, you can open up a PowerShell, and in that you can just type Aptos. So go ahead and open it and just type Aptos. So you will be able to see the output that will come from that. Give me a second. So this is the Windows method. You can go to the Aptos CLI releases page over here and download Aptos version 3.4.1. So you can find it over here. Under assets, you can go ahead and download this particular one. And then what you'll have to do is, as I've explained, just edit the environment variables, find the path variable, and in that you can just go ahead and edit it and add it as a new entry. Uh, Prakash, is my screen not visible?
Hey, hi Sneha. Can you share your screen again?
Let me share. Is this visible?
Yep.
Okay, I'm getting a comment in the chat. The screen is not visible. Can you please check what's happening?
I think you're good to go now. It is visible. I can see on the stream it's visible. Can you hear me? Sneha, your screen is visible.
Okay, sorted. Then I'll just go ahead. Okay, so I guess now we can start moving on to the part of the terminal. So I'll just go ahead and share my terminal from. Okay, okay. So now that we have the Aptos CLI installed, if you just run Aptos, you'll be able to see that, hey, this is like the output that you should get, that the Aptos CLI installation is now complete. So what we can do is we can create a new directory over here. So this is for our online workshop. I'll just go ahead and cd into it. So we're just creating a new directory over here, and then we're just entering into that directory. What we can do right now is just run a command known as aptos init. This will just allow us to spin up a new account. So it's asking me to choose what network I want to do it for. I'll just go ahead and click enter, which will take the default value of DevNet. Private key, I don't already have an account. I don't want to import an already existing account. This will be uh, just, I'll just won't give it any input, meaning that I want it to be a new account that can be generated. So it's generating the key for me. And as you see, it's saying that, hey, this account doesn't exist. We are creating it and we are funding it with these many octas, which is basically one Aptos. So our account has been created and it has been funded with one Aptos. Now, for people questioning here that, hey, is this real money? No, this is not real money. We are on the DevNet, which is like a test network for Aptos for developing applications. And for this particular network, whatever money that you have, it's not real money, it's fake money that has been created so that you can go ahead and actually create applications and do transactions that will require gas. So that's why you're already funded with one Aptos. Okay, so now that we have sorted out this particular account has been created with for us the 0x account, and if I just do a ls in this directory, uh, like there's a dot aptos folder that will be created because it's a dot aptos folder, so it's probably hidden and it's not showing over here, but I will show it to you in our VS Code system. So now what we can go ahead and do is that we can go ahead and create a new directory structure here. So we'll just go ahead and create something like Aptos move init hyphen name. I'll just call this workshop. So the first command allowed us to spin up a new account. This command will allow us to like create a setup directory structure for creating an application on Move. So this is something similar to how we already have create React app and all of these things that allows us to just create some boilerplate structure. It's just going to do that for us. So I'll just go ahead and click enter. In the case of this hyphen f name, you can go ahead and just say anything like I can go ahead and call this jelly bean if I would want to. You can just go ahead and call it whatever you want. And you can just click enter and this will go ahead and create this particular directory structure for you. And now if I just go ahead and run ls, you'll be able to see that this particular directory structure has been created for us over here. So I'll just pause for a minute here. So the first command that we ran was aptos init. Second command is aptos move init hyphen f name, and you can give it whatever you want over here. So yeah, just gonna pause for a minute now. Any questions so far? Feel free to ask in the chat. Okay, cool. So awesome. So let's continue with the terminal screen. Mm, So I'll just go ahead and I will open our directory, and we have the, yeah, this Aptos Virtual. So I'll just go ahead and open this up. So as you can see, I'd mentioned that we will have a .aptos folder over here. And this is just having the information about our account over here. So the account that we had created by running Aptos in it. If you see over here, we will have the private public key and the account address and the URLs, just basically setting the URLs for the devnet because our account is created on the network devnet. And the rest of the directory structure that we see over here has been created by the Aptos move init command that we had ran before. So this sources subdirectory that you see over here, this is where we'll be keeping all of our modules, which is our smart contract. And the modules will basically have a structure which will be ending with dot move. So I'll go ahead and create this hello underscore blockchain dot move file. So let's go ahead and create this particular file over here. And test is just to like write any sort of test that we want. Scripts is to just maybe call some of these module functions and put it together in a script. So that's on that trend. The move.toml file is the main configuration file. This is similar to how we have package.json for any sort of JavaScript applications that we create. So it just has the information about our package, the name, the version, addresses, dev addresses, and any sort of dependencies that we have. As you can see, we have a dependency defined here for Aptos framework, which is our main standard library. So this is something that when you will try to run the compiler, this is a GitHub repository that we will try to download at that moment because this is a standard library from where we'll be getting a lot of the existing functionality. So yeah, that's how we have defined all of these things within our move.toml file. Now, the next part for us is to actually write our hello underscore blockchain dot move smart contract. So I just want to very quickly go ahead and show you a little bit of the code.
I think Sneha got exited from the stream. She would be just back. She is here.
Okay, are we good to continue? Prakash, I
Yeah.
think I got disconnected. Okay, cool. Awesome. So I'll just go ahead and share my screen. Okay. So if we see over here, uh, mm, just go ahead and create our first smart contract. So I just want to show you this first move module example over here. Um, as I mentioned earlier, so the workshop that we will be focusing on today, uh, this is just going to be attaching a message resource to a particular account, and if it already exists, we're just going to go ahead and overwrite that particular message resource. So, if you see over here, we have the sources and we have this particular code. I'll just go ahead and share that link on the chat so that Prakash can go ahead and share that with you. Okay, so now if you look at this particular code, I'll just wait for a minute so that you folks can just open this up and we'll just very quickly go over this code. Feel free to ask any questions that you have in the chat. Okay, so let's continue on with the workshop. Um, yeah, so this is the code that we have. I'll just take a moment to explain you how the syntax works. So first of all, we have this module keyword that you see in the beginning, which is just saying that, hey, this is a module, this is a smart contract that we are setting up here. Followed by, this is the deployer address. This is the address that will be deploying this particular smart contract, followed by the name of this particular smart contract module. So this is message, the module name, hello underscore blockchain, it's an address. So you might ask, where is this address coming from? So this address is something that we are setting in the move.toml file. I will show you how this looks like. Give me a moment. So if you just see over here, we have the move.toml file for this particular example. And under this addresses, this is where it's taking the value from, this hello underscore blockchain. So that's how the value is being set. We, in our example, for deploying, will be setting it to our own address. Now, let's continue. So if you see this module, hello blockchain message, and then this is just, we open up our parenthesis, and in that we have whatever code that you want to keep. We start off with lines from 2 to 5. All of these are use statements, which are basically just like import statements. We're importing all of the libraries that will be requiring for this particular smart contract. STD refers to our main standard libraries, and so does Aptos framework. These are all present in the 0x1. The address that they refer to is basically 0x1, where it's all being stored. And we are taking a couple of these libraries here, like couple of things like error, string, signer, and Aptos framework event. We'll be seeing later on where and how these are used. I think error and string are pretty self-explanatory, but the other ones, we will see how they are being used. So now, as I mentioned earlier about resources, resources are special type of structs which cannot be copied or deleted. So when we're talking about move language, we have this concept of um, resources which are special form of structs, and in terms of the abilities that they have, they cannot be copied or dropped. Now, every struct can have certain abilities. Abilities in Move are of four different types: key, store, copy, and drop. Key and store are used in conjunction for key value pairs. And when we're talking about copy and drop, these are two abilities which, whenever we are defining a resource, these are the abilities that the resource cannot have. So here we are saying that we have a comment here which says resource, and we have this struct followed by the name of the struct, the has keyword to signify what abilities the particular struct has. And if you see, it has only one ability here, which is key, meaning that since the resource does not have the ability to be copied or dropped, this is a resource. This is not a normal struct, this is a special struct which cannot be copied or dropped. So this is a resource. And here we are setting up a message. We're setting up a message and that's of like data type string. So you can have multiple like attributes here with different data types, whatever you want to save. So if you see after that, we have another struct here. This we have added this modifier which signifies that this is an event. So for blockchain, we usually have certain events that we want to throw so that uh, we the front end can be notified about certain events and how to basically process certain actions. And we can also even see this in the Aptos Explorer. After the module is defined, whenever certain activities happen, it shows up for during in the events tab. So I just want to take a minute, just want to check if you have any questions. Okay, we're good. Okay. So yeah, so as I was saying, this is just to check whatever event is being thrown here. So we have this event known as message change, and this has two abilities here, drop and store. Now, since this has the ability to be dropped, we know that this is not a struct. This is not, sorry, this is not a resource. This because this can be dropped. And here we are taking three attributes, whatever account it's the message is being associated with it, string as well. Uh, which we are like just naming as error no message, which is of the type unsigned integer 64-bit, and we're setting the error code to be 0. So whenever we want something like this is for the time when we're trying to get message from a particular account address but it does not exist, we can throw this message, and when you throw this message, when you compile and if you run a test or something, you will be able to see that 0 will pop up because that's what we are essentially throwing as an error code over here. Um, so this is similar to how we have different HTTP error codes like 403 for forbidden or 400 for bad request. So similar to that, you can define certain error codes over here for different possibilities of errors in this scenario. Now we see that there are two different functions over here. First of all, we have a get message function, and second, we have a set message function. So I'll just start off with the set message function first, and then we'll talk a little bit about the get message function. So the way that this is structured, let's talk a little bit about how the function definition syntax works here. First, we have the modifier, the visibility. So it's a public function. Entry level function is something similar to how we have main functions in C++, meaning that this function can be called directly through the Aptos Explorer. It can be called through a script, um, and it's accessible to just go ahead and call. But if it did not have the entry thing over here, you might would have to use another entry function to call this internally and then access the data. So this is an entry level function, and we are setting. We have the fun is a shorthand for function. Set message is the name of the function, and we're taking two parameters here. First, we have the account, which is a signer object, and second, we have message, which is a string data type. So what account as a signer object reflects here is basically the account that is calling this particular function. And here we have a fact that that this is being that we have this acquires message holder uh, keyword acquires keyword being used here, and a message holder. So what we are doing here is that we are notifying the compiler beforehand that we are trying to access this message holder struct which is right now in the global storage. So that's why we need to first of all set this up. If you try to run it without acquires whatever the struct is or whatever you're trying to access in the global state, then you will be shown an error on the compiler saying that, hey, you need to add this acquires statement over there. So yeah, that's how the definition looks like. And then we're just taking the account address, which is the address of the we're just calling this address of function, which is on the signer library. Getting the account address, we are checking if the account address exists at that particular like the message holder struct exists at that particular account address or not. So I just want to take a moment here and explain you what this means. So we had defined our message as a struct, as a resource. Now, a resource can be attached to a particular account, can be bound to a particular account. And what we are checking for here is that whether for a particular account address, does this particular message holder struct, is it already bound to this particular account address, whether it exists or not. If it does not exist, then we can go ahead and create a new message holder struct with this particular message, and we can then bind it to this particular account. So this move underscore to, this is also an inbuilt function. What it tries to do is it will move the second parameter that you send over here, which is in this case the struct with the message that we are sending. It will bind this particular parameter to our first account. This is our signer. It will bind this particular, it will move that particular resource in the storage for that particular account. So if you actually open up the account on the Aptos Explorer, then you will be able to see this resource being stored under this account. So that's how it's working. The else condition signifies that, hey, there is an already existing message holder struct for this particular account address. So what we are aiming to do here is to overwrite that particular already existing message holder struct. And how are we planning to do this? So we have another inbuilt function over here known as borrow global mute. Now what this borrow global mute does is that it basically takes that value, and it will take a mutable reference. This mute refers a mutable reference, like if you modify it, the actual value will also get modified. So it will take a mutable reference for that, borrow that value, take a mutable reference, pass by reference, and it will then try to update that. As you can see over here, it will update that with the new message that is being sent as a parameter over here. And we will also like to emit an event for this message change, where we are sending that, hey, this is the address for which the message change is happening. This was the previous message, and this is the new message to which it has been updated to. So this is what this particular code piece looks like for setting the message. Now, when you're talking about get message, here you can see another modifier at the beginning. It's called hash view, stating that this is a view function. We are just returning some data. We're not actually making any change in the blockchain state. So this is just a view function. And we just like we have this get message over here. It's taking the address. So we are asking it, hey, what is the particular message struct that is being attached to this particular address? And here we are getting a return data type. So if you see this particular function for set message, you would not find anything followed by this parenthesis, right? Because we are not returning anything in this function. But if you look at over at this particular message, you can see that we are returning a string over here, the string data type. Because we want to get that particular message back. And it is also acquiring the message holder struct, because we are accessing that global state. So we are specifying it over here. The first thing that we are checking is that, hey, does the message holder object exist at this particular address? And if it does not exist, then we are throwing the error message that we had defined earlier for no message, that, hey, there is no message present here, and let's just throw this particular message, right? And if it does exist, then we move to the next line, and we are just borrowing that value and just returning that, borrowing that entire struct and a dot message, because just want to return the string. We don't want to return the entire struct, and this is how the entire struct looks like. So we're just doing a dot message to capture this particular attribute and just return that. So if you see here, we have a borrow global mute which returns a mutable reference. Borrow global is just to borrow the value without a mutable reference. Since we are not planning to change the value of dot message over here, we don't need to borrow the mutable reference. An immutable reference, a pass by value would just work fine for us. So that's what we are trying to return over here. So these are the two main functions that I wanted to take a minute to talk about. I'll just pause for a minute for any questions in the chat. You can just comment by adding slash over here. I'll just show you. This is how you can just add a comment. So these are all comments. Line 7, 11, 20. These are all comments. So double slash would work fine for adding comments. Okay, so now that we have this part clear, I just want to take one more minute and talk a little bit about this final test that you can see over here. So in the last like function, what we are doing is we are defining this as a test. So we have added this modifier. We are specifying who is the account here, who is the signer entity over here, and 0x1 is the signer entity. So we have just defined this function sender can set message. We are passing this account 0x1, and what we're doing here is that we're first getting the address of the account. We are creating a test account for this address, and then we are calling a set message function, which is this message function over here. We're giving it the same account and we are giving it a message. What message are we giving it here? We're giving it this hello blockchain message over here. And what we're trying to do is we're trying to assert, we are trying to do a check whether the get message, this is the other function that's defined over here. We'll be just passing our account address, that is 0x1, whether this get message of address, whatever is returned here, is it same as hello blockchain. We are basically checking whether our set message function is working and our get message working is working fine or not. And if it's not, then we'll just store this particular error for no message. So this is what we are trying to just run it as a test. When you just run this Aptos move test, this will just work out fine. So yeah, this is basically the code that we will be copying. So what you can do is you can just go ahead and copy this raw file. Just click on this, copy this raw file, and then we can just go ahead and paste it in our code. I'll just take a moment. I'll just pause and see if you have any questions so far. Any questions so far? Okay, cool. So let's continue then with the workshop if there are no questions. Okay, let's continue with the workshop. So let's just go back to our VS Code. So we had created under sources this hello underscore blockchain dot move, and we just copied the code from the link shared. Let's go ahead and paste this over here. So this is what our code file should now look like. So this is module hello underscore blockchain message, and it's saved under the sources subdirectory hello underscore blockchain dot move. So yeah, this is where our code is. Now, before we deploy, we need to define this particular address. So you can go to your move.toml file, and under addresses, you can just create a hello underscore blockchain, and you can just pass an address over here. Now, what's the address that you can pass over here? So you can take this address from the .aptos config.yaml file I had showed you a while ago. So you can go ahead and copy this account address that you see under account, this particular address. You can just do a copy over here and go to the move.toml file. Go ahead and paste this, but also append a 0x at the beginning. So you will get something like this. So under addresses, you just added a hello underscore blockchain, and then you just copy pasted the address that we took from the config.yaml file under .aptos. If this is confusing or if you're not able to find the .aptos, You can actually also just go back to your terminal screen and you can copy the address from here as well. So just go ahead and copy and paste the account address over to your move.toml file. So once you are through with this, what we can go ahead and do now is we can just run aptos move compile, and this should give you this particular result. This might take some time for a few folks to run this particular command because it will try to fetch the git dependency. So just give it a few minutes for it to complete downloading the git dependency and then compiling your code. Just wanted to show you what will happen if we actually skip this acquires thing, right? So I'll just show you for one of the functions what happens if we do this. Now if I try to compile again, as you can see, it will not compile because it will tell me that, hey, the acquires list does not contain this type, this message holder type, and it must be present. So this is how it will fail if we forget to add this. So I'll just go ahead and add it back and try to run the function again. Okay, perfect. So I'll just wait for a minute for any questions that you folks might have. Okay, cool. Uh, awesome. So, okay, so we had completed till this bit. We had run the Aptos move compile command. Now we can go ahead and actually publish our module, which is our smart contract on the Aptos devnet. The command looks something like Aptos move publish. So we'll just go ahead and click enter. So this will just give us a packet size and it will ask us, do we want to submit a transaction for this particular range at this particular gas price? So it's telling us how many gas units will be consumed and what is the price for some whatever 100 octars, what will be the this thing. So we'll just go ahead and click enter. So it will just give us the result transaction. It will show us that a transaction has been submitted onto the Explorer. So I can just go ahead and open this link and show you. It will give us a transaction hash, whatever gas has been used, what is the unit price for the gas, um, the sender, this is our account address that we have basically published, what's the timestamp, sequence number of the transaction. This is a newly created account, so the sequence number is 0. And yeah, that's all of the information that you can get over here. And that's it. We have successfully deployed our smart contract, our first move module on the Aptos DevNet blockchain. I just want to take a moment and quickly show you how this transaction looks like. So I'll just go ahead and copy this link and paste it over here. Okay, as you can see, this function is for publishing the package. There's our move module, and it'll just show us this gas that has been used. Um, I can actually just go ahead and show you our particular account and the transaction that has been created. So you can see over here, And if you just go ahead and see under the modules, you can actually find that this is the message module that has been deployed. This is the code that we have over here that has been deployed. If I click on run, you will be able to see our entry level function set message over here. You can actually go ahead and just like connect the wallet, just add whatever string you want to add. Let's say Aptos is great, and you can connect your wallet and then go ahead and run this function. To in order to connect your wallet, you will need to install a wallet extension, a Chrome wallet extension. So you can actually go ahead on petra.app. This is Aptos's official wallet. So you can just go ahead, open this petra.app. You can download as a mobile app or in the Chrome Web Store. And just download this, and you can even run this function from here. And you can just view the get message. Just put the address and whatever, and you can view the function result as well. So this is how the entire smart contract module looks like on the Explorer. So yeah, that's about it. I'll just quickly stop sharing and uh, wait for any questions that you folks might have. Yeah, sure. Link step. I'm assuming you're talking about the Explorer link or something else. Are you talking about the Explorer link or which link? Yeah, Prakash, we have deployed the smart contract, so this is pretty much the end. I'm just waiting on any questions that these folks might have. Yeah, so I'll just quickly go over the Explorer once again. I'll just quickly explain. Okay, okay, got it. So what we did over here is we ran this Aptos move publish, which is to publish the smart contract module that we have created. It gave me the packet size and it asked me that do I want to submit a transaction? I clicked yes, and this just gave me the link of the transaction that has been submitted. And this is the hash. If you see in the link also, you can see the hash. After this transaction, this is the hash for that. So I just wanted to show you how this particular transaction looks like on the Aptos Explorer. Aptos Explorer is basically like an indexer sort of a thing for all of the transactions that are present. So if you go ahead and open this link, which I did over here, I was able to see this particular transaction. So this is just giving me some details about the transaction. Marking the status of the transaction as a success, the caller, this is our address. You can actually go ahead and verify. Since we are publishing, the function is code publish package. And yeah, it's just giving information about whatever gas has been used for this particular transaction. You can also see it over here under the balance change that this is the gas that has been used. If you look at the changes, it will say something like write module. We are writing this particular module, this message module, to our sender address, the address that we have, our account address. We are writing like these different things. A coin store is being created, a package registry is being created. So these are the different things that are being added over here. So the main thing that we're looking over here is the write module. And this is just the payload that we have given, the arguments that we have given for this function. I just want to show you the sender. This is our account. So there are two transactions. The first one was our faucet transaction through which we got this one app that was done when we ran Aptos in it. And this is the second transaction which created. And for this account, we have this module saved under this modules tab under account. You can see this message thing over here. This has the code, the module code that we have, along with our ABI,
I think your screen is not
and you
clear.
can actually go ahead
Sneha, can
and
you hear me?
even
Your
run these
screen is
functions if you'd want to, the set
Sneha. Your
message and the get message functions. Now, before running, what you will have to do is to connect the wallet. So you need to install a wallet extension,
Sneha,
Chrome
your
wallet
screen is
extension
not
for
shared. Can
that,
you hear
and you
me?
can do that by going to petra.app.com. This is sorry, petra.app. So this is basically the official wallet for Aptos. So you can go ahead and actually just install this. And once you do that, you will be able to create the account or import your already existing account that we created, because you already have the account address and the private public key information in your
Sneha, am I
config.yaml
audible?
file under the .aptos folder. So you can go ahead
Like, can you
and
hear me?
just import or even create a new one, connect that wallet, and you can add a message here. This argument 0 that you see is for our set message, the second argument, which is the message. So you can write any message you want. Um, uh, and it should be just like, you can just put it here. You can go ahead and just set this message, and you can go to the view and the message. You can go and get this message for whatever address that you want to do. You can go ahead and just view. So that's how you will be able to see under resources also. If you just scroll, then we have these three ones right now. After you set the message, you will be actually able to see this as a entity over here as well. The message resource, message holder struct will be added as a resource over here. So that's pretty much what I wanted to show you.
Sneha, can you hear me? Am I
Yeah.
audible? Your screen is not visible. I have been.
Oh, I'm so sorry. Uh, okay, is it visible now?
Yeah.
Okay. Mm, so yeah, just wanted to show this particular transaction. And status of the transaction, the function that is being called to publish the package, the sender, the gas that is being used here. And if you see our changes here, we're just trying to write a new module for our particular address, which is the message module. Um, and I also wanted to show you this sender account over here. If you just go ahead and click on this particular account, you can go to the modules, and you can see our code, source code, which is over here. You can actually interact with these functions if you'd want to by setting the message and getting the message. And for this, you will require to install the Aptos wallet extension, which is available on petra.app. So this is just a wallet that will allow you to interact with our set and our get functions. And you can go ahead and call this and set it to any particular string that you would want to set it to. And similarly, just go ahead and get the message by passing the address to which that particular string has been attached to. So yeah, that's pretty much it. Okay, yeah, that's about it.
Thank you so much, Sneha. Like, this has been like you have pretty much kept the energy up throughout the session. Like, and it's amazing that you took questions throughout. And if guys, you have any more questions or anything, you can actually send those questions in our community. We'll drop the link in the description, and you can join the community. And you can also reach out to Sneha or the Aptos team for anything specific you're building on top of Move and Aptos. So thank you so much, Sneha, for being here. We stretched you a lot today, and I think it's time you should take your good rest. And I hope you have a great weekend. And thank you so much, guys, for watching this. And please do share it with anybody who is building on top of Move and Aptos. Thank you so much, guys.
Yeah, Prakash, can we take a moment to talk about our code collision hack?
Sure, go ahead.
So, all of the folks watching this, we have a very, very huge hackathon coming up with close to $500,000 in prize pool. The Aptos Code Collision Hack, if you have not come across it, we have tags for NFTs, AI, deepen, social, and gaming. So, if you're folks into blockchain and if you have developed applications before on blockchain, this is something that you should definitely not miss as an opportunity. So, yeah, go ahead and register for the hackathon. I think Prakash would be able to share the link with you. So, yeah.
Sure, I'll do that. And like, if we are shilling, like, let me shill you one more thing that we guys have our bounties live, and we just made our AI based bounties live up to $50,000. So if you are building an AI and if you are very much active into building into AI, Spheron would love to support you. And there are bounties which are live right now. I'll drop the link in the description. Thank you so much for watching this. Have a great one, guys.
Yeah, thanks. Bye bye.